Good morning. It's a pleasure to be here. As soon as the slides get on there, we can get going. Perfect. So this encapsulates the main thing I want to get across today. I think the whole revolution we are seeing around data is quite simple. Our ability to observe is exploding, right? And anytime you can observe, hopefully you can learn from that and do it better the next time around. This is something we've known a long time. What's changed is the extent to which we can observe virtually everything and the pace at which we can read and react to what we are seeing. So let's start with an example. This actually goes back to my job before Microsoft, but essentially this happens at Microsoft at virtually every website where you go to browse a page, right? The job of a Yahoo or an MSN or a Google is to give you the content you're interested in. But in contrast with, say, searching, you come into a page on a portal without a very explicit signal of what you're looking for. So the game is based on an understanding of the content. Who likes this kind of content? An understanding of you, what you have liked in the past, what you seem to be doing today, now, right? Do the matchmaking and give you content that you're likely to consume, right? That's the core operation. What happens now? When I went to Yahoo, this was many, many years ago, around 2006. Virtually every link on a page like this would have been curated by an editor, right? And that means you can't personalize, for example. So we asked ourselves, hey, can we do a better job algorithmically? And where we landed was creating a partnership between the editors and the algorithms. And if you look at this picture here, the page is broken up into pieces. And that decision, how does the page look, is made by editors. For each piece of the canvas, for example, the top right there, right? The 4 articles, the first one highlighted. There are about 50 articles that are candidates to be shown at any given instant in time. And the human editors, they decide what goes into the candidate pool. And what the algorithm does is decide which 4 articles to show and which particular article to highlight for you to see, right? And that's essentially the way the entire page is delivered. And by the time I left, over 95% of all Yahoo page views were algorithmically delivered, right? How does this work? In a nutshell, when we bring in an article, we do all kinds of content analysis to understand whether it's about politics or sports and so on. Then we track how the article does when we show it to someone. So articles that are likely to be clicked on are likely to be clicked on fairly early in the life cycle. Those that don't get clicked on, we adjust our estimate of how likely they are to be clicked on, right? And we do this using algorithms from statistics called multi-armed bandits. Once we actually start showing these articles worldwide, right? So there are thousands of servers worldwide delivering this content to tens of millions of people. That's a huge volume of observational data to learn from, right? If I show you something in Singapore, within minutes, that influences what you do, whether you click on it or not, influences what is shown to someone in New Orleans, right? That's the pace at which this cycle of learning and refining works. And if you look at what's behind it, many of the things that we associate with big data platforms today grew out of efforts like this at the early web companies. So for example, the offline modeling is based on an enormous amount of historical data. What kinds of content have resonated with viewers in the past. We built systems like Hadoop, which was actually incubated at Yahoo, in order to manage this process, the data, the transport of information worldwide, and the analytics behind it. Once we start showing the articles, it's online learning, right, together with dynamic explore exploit. This is a very, very fast cycle, literally within minutes, right? Here's where a lot of the early work on streaming began, right? So not only streaming, NoSQL stores. So it turns out one of the most important signals is what is someone interested in the current session. To deal with this, you need very, very low latency, highly scalable storage systems, right? That led us to build a NoSQL store called Peanuts. Okay. All that is well and good, but what about the rest of us? What about the world beyond the web companies? The interesting thing is, I believe that the next step explosion, we went from traditional enterprise data management systems to web scale systems, and that was a big jump. The next jump, I think, is going to be even bigger. It's going to be bigger because it's secular. It's not going to be limited to any one vertical. Industrial automation, agriculture, schools, financial companies of every stripe, government, pretty much everywhere, we are going to be able to bring this cycle of observe, learn, and refine to bear, and it's going to change, it's going to be transformative. If you take the IoT space, these predictions are staggering. Already, the number of connected devices to the internet far exceeds the number of human beings. By 2020, the prediction is nearly 300 exabytes of data will be transferred by these devices communicating with each other. Far more than the amount of information your chats and even mine transfers. What is the opportunity we have to make use of this enormous amount of observational data? Because that's what it is. When you came into New Orleans, your plane was chatting away about the level of fuel consumption, for example, right? Your cars do this all the time. The elevators you go up and down in, people use that information to schedule maintenance today. Ecology, whole scientific disciplines are being transformed wholesale, right, by bringing observational analytics to bear. This is something that's not limited to any one area of endeavor. You have heard of Moneyball, of course, in the sports arena, right? So, as examples, what I showed you with web content, company after company is doing with their product websites. Here's an example with Pier 1, which is done on Azure. And if you look at what's behind it, I'm not going to go into this slide in any detail. But basically, it's very much the machinery we put together at Yahoo, but now not bespoke. It's there in the cloud. You come in, you consume it, right? You begin by assuming that a lot of the platform work exists and is available to you in a pay-as-you-go form factor. That's transformative, because now it democratizes the reach of these technologies to virtually everyone, okay? To make that point further, this is something we did with the Tacoma School District, right? They wanted to see if they could improve the rate of high school dropouts by knowing more about students, everything from attendance to health, right? As well as their academics, to predict who was more likely to drop out so they could intervene sooner. And the results were pretty impressive. They were able to improve the graduation rates from around 55 to around 78%, right? The big thing that I want to spend the rest of my time talking about is how clouds like Azure, and for that matter, AWS, Google, if you take the major clouds out there, what they're doing to make applications of the kind we talked about that much easier to build, to deploy, and to monitor. We're actually innovating along three very different axes. First, in terms of information, the kinds of information we allow you to store, we want to expand. SQL Server is the most widely used relational system on the planet. But then beyond that, what about documents? What about these heterogeneous big data systems like Hadoop? We have our own Azure Data Lake. What about in-memory systems? What about operational analytics? We support all of this. And that comprehensiveness is important, okay? In terms of the cloud form factor, you can come in and you can rent a bunch of VMs, rent a bunch of storage, and pretty much deploy anything you want, right? This is the most familiar form factor. Increasingly, we are now trying to provide serverless compute. What this means is, for example, you would come in and issue a query and expect to see the results. You don't worry about the intermediate step of setting up your cluster, installing your software. Now that's done by the cloud provider, right? Lastly, go even one step further. For selected vertical applications, for example, CRM, you build entire vertical suites, which you can then rent as you need on a pay-as-you-go basis. Lastly, when you look at so-called advanced intelligence or machine learning brought to bear on this kind of data, we provide a full stack. Everything from BI, Power BI is one of the leading things in the market, to stream analysis, R server, where, by the way, we acquired Revo, Revolution Analytics, which is roughly the Red Hat of R. We take open source R, we keep it open source, but then infuse it deeply into a number of our software products, and we basically provide enterprise-grade support, right? One big thing that has happened in the last few years, Microsoft has committed big time to open source, whether it's Hadoop, whether it's Jupyter, whether it's Linux, right? We are big time committed to it. We are big committers of open source. Deep learning. Much of the early research on deep learning has come from MSR. And today, things like CNTK define the state of the art. We support this. We equally support TensorFlow, other deep learning technologies. Cognitive APIs. A lot of the innovation coming out of MSR in language, in speech, in vision, it's available as REST APIs. We're also taking these and infusing them into our other software stack, okay? And the point of that, I hopefully will be able to bring across in a few more minutes. So this is the full picture. In the interest of time, let me skip it. The analysts seem to like us. Someone once told me, in these charts, you want to be in the top right-hand corner. So yes, Forrester likes us in the big data space. And if you look at these charts from Gartner, whether it's operational databases, the market where SQL Server is, or business intelligence and analytics, in both cases, you will see Microsoft near the top right. Let me jump into one part of this to give you a feel for this in a bit more depth. If you take Azure Data Lake, the Microsoft version of Hadoop and related services, you see HT Insight. If you love Hadoop exactly as it is, that's what it represents. We actually partner with Hortonworks, open source, Hadoop, available in a cluster form factor, a managed cluster, right there. Azure Data Lake Store and Data Lake Analytics, the same thing, except in a PaaS form factor, right? So I'll talk about that in a bit more detail. How many of you have heard of Cosmos? Not too many. So inside of Microsoft, over the past 10 years, Cosmos is the analog of Hadoop. Virtually every part of Microsoft uses this in an internal cloud service that my team operates. Whether it's Exchange, whether it's ads, whether it's Office, whether it's search. When you search Bing, the search results, the rankings are determined on Cosmos, right? Windows, on and on, right? Xbox, Halo, every single one of them does their analytics on Cosmos. And if you look at the numbers, they are truly staggering. Internally, there are thousands of developers who use this ecosystem. The amount of data we manage is in the several exabytes. That's a lot of zeros. Every day, the I/O we do is in the hundreds of petabytes. The smallest Hadoop, the largest Hadoop cluster that I'm aware of in production is 4,000 or 5,000 nodes at places like Yahoo and Facebook. Our smallest cluster is 40,000, 50,000 nodes, a single cluster, right? Individual queries run on 10,000 nodes. These numbers may seem large to you, but with IoT, those are the scales that we envision will become fairly common in fields like finance and industrial automation and health in maybe 5 years, right? When you want to observe everything and learn from it and optimize most of the things you do, these are the scales you need to keep in mind. And what we are doing is taking what we have, the deep experience with Cosmos, we are rebuilding it, in fact, have rebuilt it, to be aligned completely with the Hadoop ecosystem. So the Cosmos storage system is completely HDFS compatible. All of the compute is run on top of Yarn. Yarn is the resource manager that is the standard in the Hadoop ecosystem. In fact, in Apache 2.9, we, Microsoft, are managing the release of Yarn. That's how deeply we are committed to this. On top of Yarn, we support all the things you would expect from the Hadoop ecosystem, as well as our own internal SQL variants, right? So we are all in on this. One other point I want to make you think about. When you start collecting data at this scale, you need to be really concerned about things like privacy, security, compliance. In Europe, there is a law, right, called GDPR. To be compliant with this, anyone who collects large amounts of data better make sure it's in systems that are compliant. And for us, what that means is we need to make sure that our storage systems manage things through the entire lifetime, whether the data is in main memory for interactive analytics or on archival storage. So these kinds of challenges technically basically mean that the level of support you expect from these cloud systems has to go up. And when it does, it lights up the opportunities I described in the earlier part of this talk to bring your applications, whatever they may be, to the data where it can learn and be optimized. So let me stop here. I'm out of time. If you have questions, we can take them offline. Thank you.